Hi, my name's John. Welcome to another Sunday night nightcap. As you can see, in tonight's nightcap, we're in a different part of the workshop. This is where I do my welding and casting. I had a friend called in yesterday, lad called Mark Williamson, and he wants to know if I can make him a hand wheel like that, cast a hand wheel like that for him. It can be done. Mr. Pete Tubal-Kane has a video on doing it, actually using that as the pattern. I've done no casting for quite some time, so I'm looking forward to having a go at this. There's one or two modifications I'll need to make on the pattern. I'll have to put some fillet wax and radius some of the edges, some of the sharp edges. The biggest problem I've got is my sand really dry. It's not being used for at least 2 years and it's gone like dust. This is what they call green sand. I know it's sand colour, but it's green sand because it's normally wet mixed with a certain amount of water, and the sand naturally contains bentonite clay. That's why it bonds together. You can't just put a bucket full of water on there and expect to wet it. You've got to get every grain of sand damp. It's quite a lengthy process. It's called tempering. Tonight's nightcap is nearly all machining. I eventually got that 63 tooth change wheel made. I started another project, a live centre for a friend, wants new bearings in the centre point, remachining. It's actually the hardest thing I've ever turned. It was unbelievably hard. It should have been ground really, but it did turn. I did manage to get a decent finish on, as you'll see later on in the video. I'll put a little bit of more stuff of Beamish on. I've still got loads and loads of footage from Beamish when myself and Mick went across there 2 or 3 weeks ago. I've been to a car boot sale today and I didn't get anything worth mentioning really. I bought one thing off eBay. I bought a 12-inch micrometer. I'll show you that. You'd be surprised what I'm going to do with it. I bought this micrometer off eBay last week. The lad had advertised, I forget how much it was, but I bid him £8 on it and he accepted my offer. It's a nice mic, it's still in calibration. It's actually an 11 to 12 inch mic. I mean, I'm not going to need an 11 to 12 inch mic, and if I do, I know I can borrow one. But what I do need is a micrometer bed stop for my lathe. So I think I'm going to cut this off and just use the micrometer part of it. It's another one of the ones where it's got 50 thousandths on the thimble instead of 25. Really easy to read, nice and clear, beautiful quality. It seems a shame to cut it up, but I mean, I paid £8 for it. I'm just not going to use it as a micrometer. Anyway, that's the plan. Really nice bit of gear. An update on Debs. Debs is doing okay. She's back in hospital tomorrow for another injection. Apart from being very tired all the time, she is getting back to her normal self. But now she's getting frustrated because she wants to get back to work. She's never sort of been off work in her life. She's always worked. Anyway, she's definitely on the mend. Right, I've started to set up the dividing head on the mill machine table. The head's got 2 pins in which keep it in line with the T-slots. I've checked it is in line with the T-slots. The other thing we must make sure is that the plane of this face here is straight up and down. If that's straight up and down, it means this is going to be lying parallel to the bed. I've got a clock gauge clamped onto the machine, touching that face. I'll zoom in so you can see it. Right, we'll wind it into a 0, which is there. If we wind the table up, bollocks, that was my fault. Right, we'll 0 it again. Zero there. Wind the table down. You can see we're getting no deviation at all. That is touching in it. That is touching. Yeah, we're getting no deviation at all, which means that is at 90 degrees to the bed, so the centre hole is going to be run parallel to the bed. There's 2 clamping bolts. We'll clamp them up so it can't move, because the head can actually tilt only up the vertical, in fact just past and just down below centre. Right, we'll try it once more. Zero. Right, that's possibly moved the fanny's hair, but nothing to worry about. Right, we've got our tailstock, or our tail centre in. This is on dowels as well, so it can't twist. So all it adjusts is the height. And the height actually looks excellent. I'll bring the camera down so you can see a bit better. Right, as far as height goes, that's the same height. Right, this is the cutter we're going to use. This is a number 7 cutter, which will cut teeth from 55 to 134. Now on English cutters, this should be a number 2. They're obviously numbered different in China for some unknown reason. On the back it tells me the depth of cut is 147. So I write 147 down somewhere. 147 is the highest snooker break, I'll remember that. Not that I've ever had a 147, but I've seen a few. Right, we need to know the thickness of this gear. The gear is 212 thou thick. So I write down 147 and 212. 147 and 212. Right, I've wrote them on there so I won't lose it. Right, the cutter's going to be going clockwise that direction, so it'll be cutting that way into the blank. Now we're putting it on that way, so we're feeding that way into the cut. Neat that up. Right, we need to ensure this is set on centre height, which is the reason we measured the thickness of it. Right, so the centre of the cutter is exactly on centre height of the job, that's important. I've got the table locked off at that height, and also the Z-axis zeroed just in case something unfortunate happens. Right, we've got our driving dog all set up. We'll put our job in between centres. This tailstock centre is adjustable. Take all the play out of it. It's only going to turn on once, so you can have it snugged up nice and tight. There's an Allen bolt there which nips up and stops it moving. Right, so we've got no play at all on there, but obviously it still will turn. Right, we need to fasten the driving dog onto the job and also fasten it into here so it won't move. what I'm looking at here is will there be enough clearance after I've cut the tooth, which is, I'm going to cut this all the way through, which is there. Yeah, there's plenty of clearance between that and the right, so let's tighten things up a little bit. Tighten the two 10mm bolts in there. Right, so that's now fixed solid to that plate. They move, or they do it because I've got to tighten that one up. Once that one is tightened up, they're locked together. That one moves, and we use our indexing pin on here. And so our pin goes through the plate we made, through the indexing plate on the front, and we'll tighten that up. That's it locked up, ready to cut the first gear, cut the first tooth. Right, we need to set up when the cutter touches the job. When I used to smoke, I had cigarette papers which were 1 thou and a half thick. I've got some paper here which is 4 thou thick, so I'm waiting to feel the resistance, and that's it there. 4 thou is a bit more than the fanny's hair, so we'll zero off that axis. Right, the number was 147 plus 4, so that gives it 151. We'll call it 150. Right. Right, 150. We'll lock the axis off at that. We're going to try doing this all in one cut. Right, I've got everything locked off. I've got the mill running as slow as it'll go, and we'll try for it all in one cut. My favourite cutting fluid for aluminium is WD-40. Right, we'll give it a try. No problem at all. Right, now we need to move around one tooth. I'll just mark that. Right, that's one tooth locked up. I have got a power feed on this and I'm going to use it. Move the clutch cast iron, the same as cutting this aluminium. Right, on one more hole. Oh yes. We have teeth. The thing with direct induction is I can disconnect it, and that is pretty good. Happy with that. Nice clean sharp teeth. I've got the 72 tooth gear set up on the mandrel in the lathe. I thought this was cast iron, it's not, it's steel, and the teeth have been hardened. I've tried taking light cuts off it and it doesn't like it. I'm going to try taking it all in one cut just to take the teeth off. I'll slow things down a bit more. Hard that bastard. Bastard stuff. I'll creep up on this side and get it right. Still 25 thought to come off it. Try and get the chips a bit no matter what I do. Because you can probably feel this little bastard. Horrible. that's at 4.6 45. We want 4642. So I take one more cut on the same setting, like a spring cut, and that should be the job done. Four six four two 4643. That's pretty good. That's really decent steel, that. I just hope this Chinese cutters will do their job on it. So we'll put our indexing peg back into the next hole round, tighten that up. And all I'm doing is a nice slow power feed and just let it slowly plod its way through. So back at the beginning, you take the pin out, turn it around to the next hole. You can't go wrong with this. Right, pin in, lock it up. Right, I'm eventually down to the last tooth. So there's Chinese gear cutters that I bought, which would be a waste of money. Have performed very well on this bit of really hard steel. I definitely think that for a mechanic that pisses about, that's a pretty good gear. There's some slight rags on the back there. I'll just knock them off on the wire wheel on the grinder. One last job. That's just a market, 63 teeth. Now I need to make a 40 and a 120. I think I'll buy a 120, they are available. I've got a bit of steel I can make a 40 out of. There's one or two people inquire about having these made. If they can supply the blank with a hole in the kiwi in, I'll certainly cut them. I'll look into getting material to make blanks, but as you can imagine it's quite time consuming. I certainly won't be doing any more gears like this unless I can really soften them. As you can see, the cutter is unmarked really. Now having it nice and slow with plenty of coolant on, still nice and sharp. Right, before you do that, you're going to take it back to the beginning, you fucking clown. Oh, it would make a good size steering wheel for a traction engine, that wouldn't it? Like a half size sort of thing.